Hello and welcome to Campus Voice, STEM Beyond the Lab, your weekly student-led feature where we bring engineering and innovation out of the lecture halls and into the real world. I'm your host, Grace Jenga, and today we shine a spotlight on a brilliant final year student who's been working on a fascinating capstone project. Joining me in studio is Benjamin, an engineering finalist here at the Technical University of Kenya. Benjamin, karibu sana. Welcome to the show.
Thank you, Grace.
Okay, so Benjamin, let's kick things off. Tell us the name of your project and in simple terms, what it's all about.
Okay, thank you. Hello, everyone. I'm called Benjamin Odiwer. Yes, as you've heard, I'm a finalist doing my civil engineering. So my project is about having a comparative study, assessing the rigid and the flexible pavement, and also assessing their sustainability and their environmental impact. So the project deals with the kind of pavement layers. I don't know whether you're familiar, but the road surfaces where vehicles skid or vehicles roll over, they're called pavements. So there are majorly two. We have the flexible, which are the ones we normally see, the tarmac roads, and we also have the rigid pavements, of which an example is located there along Mbagathi Road.
Yeah, okay. That's a lot. Okay, Benjamin, what inspired you to choose this particular topic for your final year projects?
Okay, my source of inspiration is just as I've said, a majority of our pavements here in Kenya are the flexible. These tarmac roads, they are the majority. And we have a minority, which are those rigid pavements, which are majorly made of concrete. They are very few, like a notable example in Nairobi, it's only the Mbagathi Road. So that's what personally inspired me, because I was curious to know why are people not venturing much into making these rigid pavements. And so I was curious to learn more about it, because like an example of that Mbagathi Road, uh, it was constructed by the Chinese, and upon construction, they were saying that after 50 years is when you will make a repair of it. And we have these other roads that we are used to, where after every 1 year, we usually do repairs. So I was curious to venture and learn more why or what makes the differences between these pavements, and why do we opt majorly on the flexible pavements and not the rigid pavements.
Okay, so Benjamin, was there a specific problem you're hoping to solve or a gap you saw in society or in the industry?
Yeah, to a problem, yes, there was, as I've highlighted on maintenance, it focuses on the sustainability part of my project, because the flexible pavements, they are good, but their sustainability is a bit wanting, because after every year, an example that I've used in my project of Jogoo Road, uh, every now and then there are maintenance done on it, there are repairs done on it. So that's the problem that I was seeking to solve. And to the gap that arises is there's this less venturing to the rigid pavements because of their cost. They are expensive but durable, and the amount of money incurred yearly by the government in repairing of these flexible pavements are so that the government can invest once in rigid pavements, which will take a long span of time, and it will divert the amount of money they spend on infrastructure in the line of road to different amenities which can help us as a country.
Okay, I get you. Now, let's break it down for our audience. If you had to explain your project to someone with no technical background, maybe a high school student or even your grandma, how would you describe it?
Well, to describe my project in that simpler sense, I will use the simple thing of how the pavements appear. Like when you see a rigid pavement, it has that less black of a substance, because it is majorly made of concrete, and concrete has a composition of cement, water and some aggregate and sand, and it has a grayish color. But to a flexible pavement, it is dark in color because of the components that make it, like the components of bitumen, tar, which is dark colored. So for a kid to understand, I will just use that simple analogy of the appearance, because going into the detail, it will make it a bit complicated.
Yeah, and actually confuse us.
Sure.
So, what tools, systems, or materials are you using in your project, and how do they all come together to solve the problem?
The tools that I'm using, or my project is majorly based on that environmental impact assessment. So the tools that I use are, there's the collection of data, and I, in the execution of it, seeking help from engineers who have been in the field and have interacted with it. And the major tool that will be assisting me, or has been assisting me in my preparation for this project, is something called the life cycle assessment, where we have been doing analysis of the different pavements, and it has helped us to determine the lifespan of these pavements, and also their environmental impacts, in assessing things like carbon footprint and things like the health implication effects that come about. Because yes, there are these two pavements, but in one way or another, they all have disadvantages to the environment. And so what I've been trying to assess in my project is getting everything right, and now, as we'll be having the conclusion of it, to know which one has less effects to the environment and can be now adaptable to the environment, uh, in line with the SDG goals on sustainability.
Okay, okay. Let's be honest, no project is without a few bumps on the road. What have been some of your biggest challenges along the way?
Well, to the setbacks that I've had, my project involves a lot of research and less of lab work. And also, this life cycle assessment, there are other complicated tools that, as a student, I cannot be able to get access to them in doing the research. So these are some of the challenges that I've had. And also with people are know that engineering is all about like getting hands-on, it's that technical. And so with this project, it deals with more of research, the research part of it. It now comes as after the much of the technical work has been done. So the challenge that I've had is like people trying to inquire like how, so you don't have to go to the lab and stuff, but majorly it's on that life cycle assessment tools that are necessary to collect this data. So without liaising with engineers and consultants, that's where the problem has been, on how can I do it if I would have not found help or information from these engineers.
Okay, okay. So, Benjamin, looking beyond the campus, how do you see this project being used in the real world?
Majorly, the focus, I've narrowed it down to Kenya. My main objective is that selling out this project, especially to the government, they will now evaluate for themselves whether we can be continually year in, year out repairing the roads, or we can work on long-term plans where we construct roads that last for long and save us a lot of costs which we spend here.
Okay. So, after the long university strike that saw learning interrupted for months, many people are actually questioning the value of higher education. How do you think projects like yours help rebuild that public trust?
Well, to the questions that people are having on higher education, yeah, it's true that there are loopholes in the education system, but we cannot deny the fact that there are also some positive impacts that it has brought to us. So, how I think the project will help rebuild the public trust is that it will help the public even by them themselves analyzing with the examples that I've used in my project, that's Mbagadi and Jogo, they will see on how the outlook of those road systems are, those pavements are, and by them realizing how it is, they will now get to understand that this is something that was not far-fetched, but it is this high educational knowledge that has helped me to come up with this kind of project.
Okay. So, looking back at the whole process, what would you say this project has taught you, not just as an engineer, but as a problem solver?
Well, I didn't know initially on some of the health complications that come about just from the road structures, because we've thought or we've known from childhood that tarmac roads are better than maram roads. So I never knew that these roads, they have some health impact on the drivers and even the passengers when they use those pavements. So in my project, I've gotten to understand that health effect bit that comes about when these roads get used by vehicles, when the vehicles are traveling on those pavements. And I've also gotten to know of how even these pavement structures go a long way into ensuring that we have sustainable living standards as well as sustainable infrastructure that can help countries or can help the world to meet these development goals that we are aiming to achieve as a world, that to help in the years to come.
Okay. And finally, for students who will soon be starting their capstone journey, what's your best piece of advice?
What I just say is that in whatever you're studying, seek that line that you are interested in it best, and exploit every avenue in those lines that you see that you are enjoying in your field of study, and get the best out of those areas that you are seeking. Like, extract the best from those things that will even make people wonder whether those things were actually in that field. So it just aligns with follow your passion and follow where you see opportunity in whatever you seek to do.
Okay, Benjamin, thank you so much for joining us and sharing your journey beyond the lab. We are rooting for your success. And to our listeners, thank you for tuning in to the Campus Voice STEM Beyond the Lab. Join us next week as we meet more students pushing boundaries, solving problems, and proving that learning goes far beyond the classroom. Until then, I'm Grace Jenga. Stay curious.